Good afternoon. I'm Tim Boyer, and formerly of the National Oceanographic Data Center. We're now called the National Centers for Environmental Information, which has absorbed the National Oceanographic Data Center in the U.S. And I'm giving this talk on behalf of the JCOMM expert team on marine climatology. And full disclosure, I'm not a member of that team. But I do have a great interest in the marine climate data system, which is what I'm going to be talking about, as well as the WMO information system, which I know less about, but we'll mention here as well. And talking about the structure of data flow and how that feeds into the UN Decade of the Ocean. So you've seen this before in two other talks. It's directly from the webpage for the UN Decade of the Ocean. But I wanted to direct you to the wording there that talks about the UN Decade of the Ocean is gather ocean stakeholders worldwide behind a common framework that will ensure ocean science can fully support countries in creating improved conditions for sustained development of the ocean. And common framework, that's something that's definitely the marine climate data system that I'm going to describe. And while I was on that webpage, I saw this as well, which is also germane. And just recently, the WMO signed an agreement for cooperation on ocean observations with the IOC in support of the UN Decade of the Ocean. And the Marine Climate Data System and definitely the WIS are they're joint creations. They're from JCOMM, but a lot of it has come from the WMO side. So this is a good application of the cooperation between WMO and IOC. So JCOMM and Nadia just gave a very nice talk on JCOMM and how it's changing into the future to meet adapting needs. But JCOMM facilitates marine observations and their utilization in operations, in ocean climate assessments and prediction, and in new understanding of ocean process. So go from in situ observations through these intermediaries to get to that downstream services, such as the Global Marine Distress and Safety Service. So the system can only function with a coherent structured data management. And that data management, so part of that is the GTS, which you've heard about and you'll hear about more from Kevin O'Brien, delivers real-time data for operational purposes. So this isn't these boxes. I know the GTS is really small here compared to the Marine Climate Data System, but that doesn't reflect their worth or the amount of data they're handling, just that the GTS is basically the near real-time data for that operational oceans and forecast systems. The Marine Climate Data System, that is what would be termed delayed mode, more data for longer-term use in those climate assessments, in research, but also in support of those downstream services. So as I said, I'll briefly touch on the WIS here. So WIS is working to update the GTS for distributing real-time data, including marine met data and ocean profile data as well, subsurface ocean data. And this is just a view of the GTS as it's built up over the years organically. And this is just the European system here. So it is quite a complicated system. And WIS is working to update that GTS system for the present and for future needs. And again, Kevin O'Brien will talk about this in his forthcoming talk, and there's also a poster on WIS 2.0 in the poster room. So now turning to the delayed mode part, the marine climate data flow, the data system, and you saw this in Nadia's talk. This is how do we set up and populate the marine climate data system? What is that data flow? And it starts from the first part are data acquisition centers. So those entities which first get the data from the measurement systems or from the primary investigators of those that take those measurements. And so you have marine meteorology, both delayed mode and real-time data assembly centers, data acquisition centers, and that's basically on the WMO side, mostly on the WMO side, but on the IOC, IODE side, you have National Oceanographic Data Centers, you have, I know what all of these stand for, but I'm sorry, I can't remember them at the moment, but they are all different entities which acquire data, original data. And then that data flows up to global data assembly centers, and these are assembly centers, and I'll talk about a few of those, and those IODE and the marine meteorology type of DACs, and something like The example I always use is Argo. The data flows from the regional DACs or even country acquisition centers up to the global centers. And then from there, in the Marine Climate Data System, the data will flow to what are called Centers for Marine Meteorology and Oceanographic Climate Data. And there will only be a limited number of these, and one covering each for particular types of oceanographic data. And I'll talk more about those in a little bit. And then from those centers will create, will assemble all the data, but they will also create products. And then they will push the data out to user interfaces, back to the WIS to join that real-time data, and to, and this is a little bit outdated already, the IODE's entity for data. So to kind of break that down and simplify it a little bit, we have basically, you see here the DACs flowing into the GDACs and up to the CMOCs. And so 6 to 10 areas are envisioned for the Marine Climate Data System. And this was built, the basic idea came from the MCDS, the Marine Climatology Survey Scheme, which was the scheme that's been around for quite a number of years to get oceanographic data, marine met data to centers to create maps, climatologies of regional weather conditions. So this is the idea here is that IODE, the International Comprehensive Ocean Atmosphere Data Set, will be the CMOC in the marine meteorology area. And there's also the ocean profile area, and that's where the World Ocean Database will be is set up as the CMOC as of the last JCOMM meeting. And then there's also ocean trajectory. And actually the first CMOC was CMOC China, which is the end point for data products for drifting buoy data and other types of trajectory data. And there's already a setup there where Canada and France both are GDACs for drifting buoy data that feeds into the CMOC China. So why do we need the Marine Climate Data System? Well, one reason is to bring some clarity to the submission points for data. If you have this system, anybody who has data can know, where do I go in this system? Where do I put my data? And coupled with that, it brings clarity on how and where the data submitted will be disseminated. Okay, so I put my data in at this point, what happens to it? The Marine Climate Data System will say it'll go to this point, then to this point. So you know what happens to the data you're putting on the system. And this, of course, implicitly will help towards standardization of forms, metadata, quality control procedures, and so on. Because if you are now part of a system and you have to pass data to a DAC or a GDAC or a CMOC, you need a mechanism to do that. And the best way, of course, is to standardize those mechanisms of passing data. And this will encourage dissemination and sharing of marine data. If you have a system, if users know where to go to get that data, then it's much easier for them to get data at a regional level from a particular type of instrument, or just all of the data from a particular ocean variable. And that, of course, brings clarity to a user as well, looking for that specific or general type of data. And this will bring recognition of a contribution, of the contribution to the data set. So it's a way to say, to show your national government or international entity, look, I'm contributing to this marine climate data system. This is an international way to share data. So these will all facilitate getting data through to the user. So here's an example, and this is what I'm involved in. I'm a manager of the World Ocean Database. And so in assembling the ocean profile MCDS, we're not completely there by any means, but we have a good starting point. We have a lot of programs that have been there for a long time. For instance, Argo's been around since 1999, and they have a system already set up of DACs. They have 2 GDACs, one in Monterey, California, one in Brest in France. So those GDACs then can feed into the CMOC. The GTSPP program, Global Temperature and Salinity Profile Program, which Nadia mentioned, which has been around since 1989, and it basically works well already, assembling real-time ocean profile data off of the GTS, and also from many different sources, and also replacing that for some types of instrumentation, especially the expendable bathythermograph with delayed mode data. That all comes through GTSPP, and that flows up to the CMOC. Another, and this has been mentioned in a few places, the CCHDO, the CLIVAR and Carbon Hydrographic Data Office at Scripps Institute in San Diego. They get data from GoShip, previously from WOS, which was also talked about here. So all of those data from those cruises, by design, are supposed to be sent to CCHDO. Then CCHDO feeds up into the CMOC. But that doesn't mean you need to get the data from the CMOC. If you're only interested in that GoShip data, you can go to CCHDO. You should go to CCHDO. If you're only interested in the Argo data, get it from that point. But if you want all of the temperature or all the salinity profile data, you might want to go to the CMOC. So a lot of things that really need to be worked out still are where the NODCs fit in here. I mean, basically, an NODC would be a DAC for a particular country, and then that would feed into the system that way. But there's some institutes, like for instance, if you have a GoShip cruise that's sponsored by a particular country, that data is going to go to CCHDO as well as to the NODC. So some of these things really need to be worked out yet. And for instance, the gliders. Gliders right now, there are three main points, DACs if you will. There's the IODE in the United States, there's IMOS in Australia, and there's EGO in the European Union, which is evolving. And there's, in the works, is a GDAC. I know JCOMM is working on this, a GDAC for glider data, so that those three centers can just flow into a GDAC and then up to the CMOC. So there's a lot of work still to be done on assembling the marine climate data system. So what actions can be taken to prepare us for the decade of the ocean and getting this data system together? The expert team definitely has some actions. One of the criticisms I've heard, especially very recently, is, well, what is the marine climate data system? I don't see anything about it anywhere on the web. So one thing that the ETMC needs to do and is doing, Dave Barry in the UK, is constructing a website to kind of gather the information about the marine climate data system together. And this will be the main location for that information. The ETMC is also taking the lead in promoting the development of the MCDS, but their emphasis, not completely, but is mainly on marine meteorology. So we really need the IODE to work in here and to help with the oceanographic side of this. And then a suggestion, the new chairman, well, for a year now, from the China Meteorological Administration, it really would be good to work with IODE to promote the marine climate data system, so we can promote it both from the marine meteorology side and the oceanographic side. So what can IODE do? Well, IODE can really play an instrumental role in assembling the already existing structures into a formalized MCDS structure and send out official invites for contributors for specific roles, DAC, GDAC, and so on. Especially facilitate, IODE is in essence the collection or an international facilitator of national oceanographic data centers. So help the marine climate data system incorporate the national data centers. And well, we need to relate the ODIS, which we've heard about quite a few times here already, the listings that are going to be on the ODIS, how do they fit into the structure? Where possible, where we can fit that in, so people know exactly where to go to get that level of data which they would like. And of course, promote the MCDS, both to the data providers and potential entities within the MCDS and to marine data users. Thank you.